So compound inequalities. Remember, when we're dealing with inequalities, you want to treat an inequality just like an equal sign, except when you multiply or divide with a negative, you're going to flip the sign. So compound inequalities. If you think about compound sentence in English, compound sentence, they take two sentences and they put them together. Same thing with compound inequalities in math. We're taking two inequalities and we're putting them together. So there's two types in general of inequalities. There are more, but this is just generalizing it down to two, where you usually have a number in between two other numbers. For example, let's say x is between 4 and 9. And oftentimes we use and to say it's in between. The other type is the or, so you could have x is less than, let's say, 4, or x is greater than 9. With each type, when you're graphing this type on the number line, you'd have the 4 and the 9, open circle, and the x is in between the two. With this type, you have the 4, open circle, going that way, and 9, open circle, going this way. And again, I'm generalizing. There are, problems out there where they can overlap, and you'll have, this going this way and another one on here going like that, and they kind of do some crazy things. But in general, these are the two types you're going to see. So we're going to approach how to solve these two types. So if we have the first type, negative 15, for example, 5x plus 20 less than equal to 40. So we're going to solve it just like we have solved inequalities all along. We're going to move things away from the x. So you look here at what's hanging out with x, and instead of just doing it to two parts, we now have three parts. So we're going to do that to all three parts. So it's plus 20. So we're going to subtract 20, subtract 20, subtract 20 from all three parts. That's the only difference from when we were doing inequalities before. So now we have negative 35, 5x, and 20. Now we want to get x by itself. It's not by itself yet. It's hanging out with the 5. So we need to divide by 5. And now we end up with negative 7, x, and 4. So x is between, we go to our number line, negative 7. We just make it like that. 0, 4. It can equal negative 7, so solid circle at negative 7, solid at 4, and it's in between the two, between negative 7 and 4. If we're dealing with the or type, they'll usually be written with two separate equations. 2x is less than 8, or 6x is less than 30. When you have this type, this is one thing on its own, you solve it alone. This one is all on its own, you solve it on its own. And then you put it on the same number line. So we're going to divide both sides by negative 2. Remember, when you divide with a negative, you need to flip the sign. Since the one doing the division is negative, we're going to flip the sign over. So now we have x is greater than negative 4. Or, on this side, divide by 6, x is less than 5. So on our number line, negative 4, it cannot equal negative 4, so I'm going to put an open circle there. And let's see, 0, 5, and again, it cannot equal 5. So I want less than 5 and greater than negative 4. It is going to be between those also. All right, next one. What if we have one that looks like this? 6x is greater than or equal to 1, and negative 4x is less than 11. So again, this is one where there are two separate things, so we're going to solve them individually. So this one, x is greater than or equal to 1/6. This one, I add the 1. Negative 4x is greater than or equal to 12. Divide by negative 4. I'm dividing by a negative, so we're going to flip the sign. When you put this on a number line, you will see, I'm running out of time, they're going opposite directions. 1/6, so they go opposite directions. Phew.